All right, we had a little bit of homework last night, 479, some practice problems, and we had 3 multiple choice questions. Somebody just asked me to go over question number 1 on 479. Number 2, okay? Just number 1? Okay, number 1 it is. After we're done this one, we'll take a look at all 3 of those multiple choice questions, whether we need them to go over or not. I just like to go over them with you regardless. Okay, number 1 says a 72 kilogram snowboarder gliding at 1.6 meters per second to the east bounces west at 0.84 meters per second. Notice I'm not doing anything with the givens quite yet. All I'm doing right now is, as I spot something that kind of jumps out at me as being something that could lead to a silly mistake, I'm drawing attention to that. We got east, we got west here. So we know that something's going to be negative, something's going to be positive. We got another west there, so another different direction there. What will be the velocity of the skier just after impact? This is a collision, so we're going to do conservation of momentum. Let's take care of our givens now with that in mind. Let's say that the 72 kilogram skier, let's call that M1. Let's say that the other skier, the 87 kilogram skier, let's call that skier M2. This 1.6 meters per second, this 1.6 meters per second, tell me what that is. Obviously it's a V, but is it V1 or is it V2? It's V1, it's the snowmobile or the snowboarder, right? And that's object number 1. So we're going to call it V1. Is it V1I or V1F? It's V1I. It's the initial velocity of the first guy. He bounces west at 0.84. So we're going to say V1F, the final velocity of guy number 1, is going to be 0.84. Is that right? What is it? What's wrong with it, Patrick? It should be negative, right? And I've got a very good chance of remembering that it should be negative because as soon as I saw that word west, I circled it in red to draw my attention to it. So I might forget, but man, I'm a lot less likely to forget if I've got it circled in red there. All right, what else we got here? We've got 1.4 meters per second to the west. We're going to call that V2 initial. Negative 1.4 meters per second. See, I'm not going to forget the negative. I got the west circled. What's the velocity of the skier just after impact? We're going to say what's V2F, the final velocity of object number 2, the skier. Okay, so we know it's conservation of momentum, so we'll do a thing with conservation of momentum. PI is equal to PF. How many objects do we have? How many objects do we have before this collision's taken place? We get 2, right? So let's put in 2 terms. Let's say M1 V1I plus M2 V2I equals, what do we got afterwards? We get 2 objects still, right? They bounce apart. So we're going to say 2 terms, M1 V1F plus M2 V2F. Let's plug in some numbers here. Hey, by the way, can I cancel out those masses? I haven't asked you this yet. Can I cancel those masses? Because it appears in every term. Yes or no? No, why not? They're different masses. If both skiers had the same mass, could I cancel it out then? Yeah, if they're the same mass all the way through it and it appears in every term, I can cancel it out. That doesn't happen often, but every once in a while they give us that shortcut on a diploma exam just because they're giving us a really long question and they want to make it a little bit shorter by giving us a shortcut in that respect. So listen, if you don't spot that shortcut, that's okay. But if you spot it and you cancel them out, then save yourself a little bit of work at least. All right, this one we can't. We got 72 kilograms times V1I, which is 1.6, plus M2, which is 87, times V2I, which is V2I is negative 1.4. M1 again is 72 kilograms. V1F is negative 0.84. Plus M2, 87 kilograms, times V2F. And V2F is what we're looking for here. How do we get this now? Let's bring the calculator up and we'll do it as a group here. All right, let's do the left-hand side. Let's say 72 times 1.6. We get 115.2. Now let's add to that, brackets, 87 times negative 1.4. When we do that, we end up getting negative 6.6 on the left-hand side. Now we've got to take the 72 times negative 0.84 over to the other side. How do we take that over to the other side? Do we add or subtract? 72 times 0.84. When we multiply those two numbers together, we're going to get a negative, right? How do you take a negative over to the other side? No, we're going to add it. We'll subtract the negative or add the magnitude, right? Yeah. So it ends up being negative 6.6. Let's add to that 72 times 0.84. Don't add 72 times negative 0.84. Okay, we could subtract that, or we can add 72 times positive 0.84. Okay, we end up getting 53.88 on the left-hand side. Now let's divide that by 87. When we do that, we end up getting 0.619. 0.619 meters per second, and the answer there is 0.62. We rounded to 2 digits, and that's exactly what we get. It's a positive value, so that means the final velocity is to the east. Is that good? Is that okay? All right, we also had those 3 multiple choice questions. Yeah. Those 3 multiple choice questions, it was 10, 13, and 14. 10, relatively straightforward question, says 2,100 kilogram van collides with a 1,200 kilogram car that's at rest. They lock together and move off with a speed of 4.5 meters per second. What's the initial speed of the van? Let's write down some givens here. We're going to call this M1. We're going to call this M2. We're going to call this V2I. V2I is equal to 0 because it's at rest. We're going to call this VF, not V1F, not V2F. They both go off as one object, so let's just call it VF, or you can call it V12F. We want to find the initial speed of the van, so we want to find V1 initial. Let's do a thing with conservation of momentum here now. PI is equal to PF. We've got 2 objects before the collision takes place, M1 V1I plus M2 V2I. They stick together, so how many objects do I have after the collision takes place? 1. So let's say the final momentum is M times VF. We can't cancel out the mass either here because, again, the masses aren't the same. M1 is 2,100 times V1I, that's what we're looking for here. Crossing that off, how come? Because it's 0, right? Why is it 0? Because it's at rest. If the velocity is 0, then the momentum is 0 as well. That's equal to M. What's M here? Austin, what's M? Good. So it's 3,300 kilograms. Good. And the final velocity is given to us as 4.5 meters per second. So we do our thing here, 3,300 times 4.5, divided out by 2,100. What do we end up getting for V1I? 7.07? Now this one is not in scientific notation. They just want me to put in the answer there, 7.07 meters per second. Is that good? How many people got that one right? Good. Let's take a look at question number 11. This one I thought was a bit tougher. Number 11 says, an empty freight car of mass M coasts along a track at 2 meters per second until it couples to a stationary freight car of mass 2m. We want to find the final speed of the 2 freight cars. This would be M1, and let's call 2m M2. Now this is a bit odd because we don't actually have a number for the mass here. Okay, we'll see how we deal with that in just a second, okay? What else we got? 2 meters per second would be V1 initial. V2 initial is 0 meters per second because it's stationary. We want to find VF. They couple, they stick together. So there's only one final velocity. We want to find out what it is. Now, we're not sure what to do with this when we're not given a mass. Don't worry about it. Do your thing. Okay, we know how to start this question. Even if right now you don't know how you're going to finish it, that's okay. I can live with that. But don't be flustered about how to start with it. You know how to start with this. Pi is equal to Pf. It's a collision. Total initial momentum in an isolated system is equal to the total final momentum. There are two objects before the collision takes place. So far, it's no different than any other question we've done. There's only one object afterwards. What's the first mass? M. All right, that's so we got to leave it, I guess. See what happens here. V1I is 2.0 meters per second. V2I is 0, so whatever M2 is times 0 is 0. What's M on the right-hand side? It's 3M. Right, it's the combined mass. M plus 2M is 3M. We're going to multiply that by the final velocity, which we found to be... Yeah, that's right. We're trying to find the final velocity. Right. Thank you. So we get two unknowns here, M and V, and unfortunately the M is in two places. Is there a way to simplify this pretty dramatically? What is that? Holly? Yeah, just cancel the masses. Not cancel the mass, but cancel the M portion of that mass. Right? M is M. Appears in both terms, so we can cancel it out. We're left with 2 is equal to 3 times Vf. So all of a sudden, this becomes a lot easier. Vf ends up being equal to 0.667 meters per second. So the answer would be D. Yep. Yes. How many people got that one? Okay, good. I think that's a tougher one. I don't think that's crazy. I don't think it's one that, you know, we see on a test and say, oh man, there's no way I'm going to get this. I think we can get it. But I think it's definitely a little bit tougher because there's a little bit of a twist to it, to some of the questions we've done before. Question 14, I thought there was even more of a twist to it. 14, two boys, Ted and Larry, initially at rest, push each other apart on a frictionless surface. Ted has a mass of 40 kilograms. Larry has a mass of 60 kilograms. After the boys push each other apart, Ted has a speed of 6. We want to know how either the momentum or the kinetic energy of Larry compares to that of Ted. Let's write down some givens here. Let's say that Ted is M1 and Larry is M2. Let's say that V1 final for Ted, the final speed for Ted is 6 meters per second. There are two possibilities here, two of these options that we can tell right now are wrong. We don't have to do anything to determine two of them are wrong. Which two can I eliminate right away? Which ones, Holly? Good. The ones with the momentum in it. Holly, why can I eliminate A and B, the ones with the momentum in it? Yes, they've got to have the same momentum. Now, not necessarily the same velocity. They won't have the same speed or velocity, but they will have the same momentum. What was the momentum total of Ted and Larry before they pushed each other? 0. What is the momentum total of Ted and Larry after they push each other? 0. So if Larry goes off with 10, then Ted has to go back off in the other direction with 10. So the momentum, at least the magnitude of the momentum, has to be the same. That precludes A and B from being legitimate possibilities. Well, let's look at kinetic energy then. In order to compare their kinetic energy, we actually have to calculate EK. EK is equal to 1 FmV squared. But in order to do that, we need the speed of Larry. We don't know how fast Larry is moving. So let's do something we don't. Let's say that Pi is equal to Pf. It's like an explosion, right? One object becomes two. Ted and Larry together become Ted and Larry separate. Ted and Larry broke up, I guess. They're splitting apart here. One object with 0 momentum. You know why they broke up and they split up? Because they had no momentum. They had no momentum on their sides, so how can they stay together? How much momentum do they have after they push each other apart? 0. But there's two terms that make up that 0, M1 V1F plus M2 V2F. Now, object number 1 is Ted. He has a mass of 40 kilograms. Ted has a speed of 6 meters per second after Him and Larry push each other apart. Larry has a mass of 60 kilograms. Let's find Larry's velocity. Works out to be 4 meters per second. Now the kinetic energy is easy. The kinetic energy of Ted is 1/2 m1v1 squared. It's 1/2 of 40 times 6 squared. Gives me 720 joules. Now let's get the kinetic energy of Larry. He's object number 2. Four squared is 16. 16 times 30, half of 60, is 480 joules. What's the answer to the question? Does Larry have more kinetic energy than Ted or less kinetic energy than Ted? He has less, so the answer would be D. Now, if we're just trying to do this quickly like we did the momentum thing, we said with momentum, you know, look, they push each other apart. They started with 0 momentum. This guy's got to have the same amount of momentum as this guy when they push each other apart. Why is kinetic energy not the same? Why does one guy have more kinetic energy, dramatically more kinetic energy than the other? Pardon me? Yes, yes. He's lighter and moving faster. Now, the guy who's lighter and moving faster is going to have more kinetic energy than the guy who's heavy and moving slower. How come? Kinetic energy is dependent on both mass and speed, right?